So in this video, we're going to try to prove triangles similar. So you can state how to prove triangles similar, and you can state whether two triangles are similar. This is going to be very similar to when we prove congruent, but it does have the differences, so you have to keep the two apart, but you're going to notice some similarities between them. So remember the ways we prove triangles congruent. We had 5 ways: side, 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 angle, side, where the angle is in between, angle, side, angle, where the side's in between, angle, angle, side, where the side is not in between, and for just a plain old right triangle, we could use the hypotenuse leg. Remember, you cannot prove by side, side, angle, can't spell a bad word, or angle, angle, angle. Now this is going to be different than proving triangles similar. So when we prove triangles similar, these are the ways we can prove: side, 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 angle, angle. You still can't prove by side, side, angle. Now, because you can prove by angle, angle, two triangles are similar just if the angles are congruent. We don't need these two, because both of these have two angles in them. Angle, angle. So this kind of overrules these two. So we only have 3 ways to prove triangles similar versus the 5 ways to prove triangles congruent. So that's one big difference. So the one way we couldn't prove triangles congruent was using angle, angle. And we don't need to use angle, 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 because 2 angles implies the third, because of the 180-degree rule. But these 3 are the 3 ways to prove similar. So let's look at those 3 a little more closely. So side, side, side does not mean congruent. Alright, so it does not mean they're congruent to each other. Alright, they mean they are proportional. So the sides are proportional. So a very simple proportion, I can say this is 2, 3, 4. So if they're proportional, 4, 6, and 8. They have the same ratio. So side, angle, side, we could have proportions like 2 to 4, 3 to 6. They have the same proportion. The angles are congruent. They have to be. So that angle is congruent to that angle. So angle, angle means you need 2 congruent angles. So these 2 are congruent, and then maybe these 2 are congruent. Then they are congruent by, or then they are similar by angle, angle. So these are similar by side, 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 and these are similar by side, angle, side. Again, the sides mean they are proportional. Angles are congruent. So let's see whether or not these 2 triangles are similar. If so, we're going to state what theorem, either side, angle, side, 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 or angle, angle, to prove that they are similar and write a similarity statement. So we have just angles. I have nothing to do with the sides. So the only one we possibly could prove by is angle, angle. So we have 20. So we have one pair of angles that are congruent. And then this is 85 and this is 75. So initially it looks like they're not, but we could figure out what this angle is. So we can use our 180 rule to minus 20, which is 160, minus 75. It comes out to be that this angle is actually 85 degrees. Well, then that makes this one 75 degrees. So we have similar. So we can prove by the angle, angle similarity. So now we need to write a similarity statement, which we did in previous sections. We can go triangle ABC is similar. Use our symbol for similar. Triangle A goes with D, B goes with E, and C goes with F. So are these triangles similar? Well, now it looks like we have side, angle, side, because we do have our 2 congruent angles, so that part's good, but we need to check if our 2 sides are proportioned. So we need to see if they're the same ratio. Well, we can check. This 14 over 15 is at the same proportion as 9 and 10. Now I know 14 has to go with 15 because they are the 2 bigger lengths, and 9 and 10 have to go together because they are the 2 smaller lengths. So are these the same fraction? And the answer is no. A lot of students are tempted that this one is because it looks like, oh, we're adding 1 to both of them. So then it's yes. This is totally incorrect, and it's a big misconception. For things to be proportionate, it has to be multiplication in between. Right? You are timesing. You are not adding. Okay? It has to be multiplied by the same rate. So this is no, they are not similar. Alright, so are these triangles similar? If so, we're going to get the theorem. So it's kind of like, wait a minute, where do we have 2 triangles? Well, we have 2 triangles in one. We have this triangle right here, and then we have our bigger triangle. So I'm going to split them out so you can see them better. So in the small triangle, we have 5 and 4. In the bigger triangle, we have 14, and we have 10. So we need to figure out whether they're proportional. Well, you might say like, oh, we only have 2 sides, that doesn't work. But notice they both have the same angle because they both are part of the same point. So we have congruent angles. So it's very possible that we can prove by angle side similarity. We just got to check our proportions. We take the 2 smaller lengths, 4 divided by 10. Is that equal to 5 over 14? Well, 5 over 14 is not congruent to, or does not equal 5 over 14. 4 over 10, 5 over 14, because it's 2/5, which does not reduce down. They should reduce down to the same. So again, the answer is no. It looked like it's pretty close, but it's not. And again, a reminder of like the same kind of properties, reflexive, vertical angle theorem, all those will apply and you have to look out for it. To review that we have 3 ways to prove. We have side, side, and angle. Ratios implied multiplication, not addition. And the thing you got to remember about the sides, okay, you're looking at the ratio. The ratios have to be equal, okay? The angles are congruent. Reminder to do your reflections. You get credit for watching this video.